Hey everyone, Professor Cameron here. So, what we're going to be doing this week is we're going to be running through and we're going to be going over adding in multiple tool paths to a complex part. So, this part is available to you through Brightspace, so you can go ahead and download that through Brightspace. And what we're going to be doing is we're going to be running through talking about why we designed the part this way, um, and then talking about adding in our tool paths, and then how we might adjust our stock size to accompany that. So what I want you all to do first is to go ahead and download this part. Like I said, it's available through Brightspace. And then we can go ahead and start adding the tool paths through this. Now, the way I have this part modeled is I have this part modeled with this base here. And this is something we've done before, is add this base to our part. This is two things. One, it is a space that we can clamp this into our vise, right? And I like modeling this in as opposed to using the stock manager because it makes the process a lot easier. So this is 3 inches by 3.5 total, and we're going to cut this into a 3 by 3 cube. Now this is something you might have to do in Solidworks when you're designing parts, right? Uh, what we're used to is using Solidworks to create our finished piece. And for a lot of the times, that's what we're going to be doing. However, when you move into the more manufacturing engineering of it, you may have to modify and adapt that model to better suit generation of toolpaths, to better suit that manufacturing process. And that's exactly what we've done here, is we've gone ahead and added this stock size in. So what this would be emblematic of is a stock size that we get. You know, we're buying stock, and when we buy stock, we don't always get it in the exact size that we need it. And sometimes it's not efficient to cut it down to the exact size that we need it. Sometimes it's more efficient to machine it away from a larger piece, and that's what we're doing here. So what we have is 3.5 by 3, and we're going to machine this 3 by 3 cube out of it. So what we're going to start with first is just like we always do. We're going to define the machine. We're going to be doing a mil in inches, and then we want to use our custom tool crib, the tool crib that we did last week. So make sure that that tool crib is selected, and we can go ahead and select OK. Once we've done that, what we're going to do is we're going to not generate our coordinate system. We're going to generate our stock manager first. And the reason will be apparent to you in a second. But for the most part, this is what we want. We want our stock bounding box vertex, and we want to add some material to the top surface here. So if we get this in a side view, and we zoom in here, we can see that we have just a thin skin of material on the surface. Now what we're doing here is we're adding 10 thousandths, because what we're going to do after we machine this, after we machine all the pockets out, is we're going to come through with a face mill. We're going to face mill that surface off. So we're going to add 10 thousandths to our stock size to go ahead and grow that. Now you can see here, because of how I have this modeled, I'm adding it in my Y. Now when we go ahead and generate our coordinate system, we're going to flip that around a little bit. So we may have to do some tweaking here. But what we're going to do is we're going to go ahead and add 10 thousandths in the Y. And that's going to add 10 thousandths of material to the top of our part so that we can come through and face that off. Now this is important to do before we select our coordinate system, because we're going to select this corner here as our origin for when we go ahead and mount this into the machine and zero that. We can't use this surface here because it hasn't been machined yet So that's why we had to generate the stock first. So we're going to go ahead and select that. Now we can go back to our coordinate system. We're going to select stock bounding box vertex, and we're going to select this corner right here, this front right corner. Now we want our triad, we want our axes to be going in the right direction. We want our x-axis going this way, our y-axis going this way, and our z going straight up. To do that, we're going to select this box right here, the X box, and we're going to select this edge. It's going to orient our X-axis going this direction. We're then going to select this Y box right here, and we're going to select this edge right here. It's going to orient our Y-axis going in that direction. And then what that should do is orient our Z-axis going straight up so that our triad looks exactly like it does here. Once we've done that, we can go ahead and select OK. What we're going to do now is we're going to go ahead and select Setup and Mill Setup. And essentially all we're doing here is telling it which way we want Solidworks to recognize the features at, or essentially which way is down. We're going to select this top surface right here and select OK. And you can see it's gone ahead and created two mill part setups for me. Mill part setup 1, mill part setup 2. And then it's gone ahead and put in some features. What we're going to do is extract machinable features, generate operations plan, and you can see it's put in an area clearance, a Z level, a rough mill. It's put in a whole bunch of stuff for us. Now, we're actually going to come in here and delete all of this out. The reason is it's easier to add these all in one at a time than it is to go back and fix all these. But let's go ahead and just generate the toolpaths, and we can see how this looks, and we'll show you exactly why we don't want to just rely on going left to right on these buttons here, why we want to go through and do this all intelligently. So what we're going to do is simulate this. Let's go ahead and slow this down here. And you can see right off the bat, that area clearance, it's carving right through the corner of our part. This is because SolidWorks doesn't always know what the shape is or how we want the shape to be cut. It's sort of doing its best guess, but SolidWorks isn't the smartest all the time. So what we're going to do is we're going to go ahead and delete all of this out here. So delete everything out of here. Yep. And then we can delete mill parts setup 1 and 3 out of here. We only need mill parts setup 1. And then we can hide all this. Very good. We only need one setup for all of this. All right. So what we're going to do first is we're going to have SolidWorks CAM machine out these two sides. So we're going to go to mill part setup. We're going to go to 2.5 axis mill operation and then rough mill. We're going to have it choose our 1/2 inch flat end mill. We're going to go to features. And we've got a few different features in here. We're going to choose rectangular slot group 1. That's the two sides here. We're going to select OK. Now, what I like to do is to edit all of the parameters for this at the end. I just like to generate all the rough toolpaths, and then we'll go back and refine them all. So let's go ahead and generate that toolpath. Just to make sure that everything, let's see. Added all those back in. Let's go ahead and delete these out. Generate toolpath. Very good. And then simulate that, and then we can go back in, and we can see that it's just coming in and buzzing off those sides. And you'll notice, if we recall, it's leaving on that 10 thousandths material because this is a rough mill. So when we go ahead and edit that parameter, we're going to tell it to remove this thin layer of material here because we don't want to come back in and do a second pass on that. So once we've got that done, what we're going to have it do is a Z level to machine out this interior pocket in here. So we're going to go to mill part setup, edit 3-axis mill operation, and a Z level. We're going to choose our 1/2 inch flat end mill, and under features, we're going to select this multi-surface feature. That's selecting this interior pocket in here. And we can go ahead and select OK. You can see it's added this Z level. And like I said, we'll figure out all the parameters afterwards. So let's go ahead and see how this looks. We'll generate the toolpath and then simulate that. Very good. Now you'll notice this surface right here is pretty rough. We're going to edit that because we have to come back in afterwards with a 1/4 inch end mill because we can't quite reach into these corners here with that 1/2 inch end mill. So we're not too worried about the overall surface finish right now. We just want to get all of the rough material out. And what we're left with in here is this little island. So we need to come in and remove that island out of here. To do that, we're going to go ahead, add in a 3.5 axis milling operation and a flat area. We're going to choose our 1/2 inch flat end mill. Our features are going to be our multi-surface feature. And what it's going to do is it's going to recognize that flat area right there and machine that pocket out. We can go ahead and select OK. We'll edit those later. Generate toolpath. And we'll go ahead and simulate this. So it comes in, buzzes out the sides, buzzes out that center, and then what it's going to do is it's going to come in and machine that out. Now, if you'll notice, that took that cutter and plunged it right down into that part. Now, we're going to be cutting this out of aluminum, so that's going to be very aggressive. So we're going to want to make sure that we come back in and fix that. But for right now, this is fine. It's getting rid of the material that we want. We can edit all of this later in the parameters. And that looks pretty good. So we've got the general shape of it cut, minus the holes and minus some refinement. What we're going to do is we've got all this interior surface removed out of here. We're going to come back in and refine this. So we're going to add in another 3-axis milling operation, and we're going to add in another Z level. But this time, we are going to be using our 1/4 inch flat end mill. Our smaller tool diameter will be able to fit into these corners and will be able to give us a finer finish on this interior surface in here. We're going to go to Features, Multi-Surface Feature, and OK. We're going to generate toolpath. And we'll go ahead and simulate this. And I like simulating it and generating the toolpaths after every tool operation, because that way I know that everything should be cutting properly and I'm not making a mistake that I have to go back and fix later. So it's a little bit more time, but it's worth it in case we make a mistake. Now, let's go ahead and start that over again. We've got the sides, got that interior pocket, we've got that island, and then we're coming in with our 1/4 inch end mill. Now, ideally, like I said, we'd be using a ball mill for this. We don't have a ball mill in our tool crib, so we're going to work with what we have. And you can see it fitting into those corners a lot better and machining out that surface. Now, what you'll notice is right here it still looks pretty rough. That's because our step down rate is still set pretty coarse. It's still set to 50 thousandths, which is what our half-inch end mill was, which is why it hasn't done anything here. We're going to go back and edit those parameters to go ahead and uh, refine that step down rate, and it'll smooth that all out for us. So this all looks great so far. What I want to do is go ahead and spot drill for these two holes. So I'm going to add in a operation. I'm going to add in a hole operation. And I'm going to add in a center drill operation. We are going to choose from our tool crib our 1/4 inch 90-degree center drill. We're going to go to features. We're going to select hole group, recognizing those two holes. And then we can select OK. We've got our center drill here. We'll go ahead and edit those parameters later. But what this is actually going to do right now is with that center drill, it's going to try to drill that whole hole out. We don't want that. We want it to just come in and spot this so that when we go ahead and drill this out with our 1/4 inch drill bit, the drill bit doesn't walk on us. So what we're going to have to do, or we're going to have to pay attention to, is to go ahead and edit the parameters so that this doesn't drill all the way down. Let's go ahead and simulate that. Sides, interior, center, 1/4 inch, and then it's going to come through and spot those two out. Now we can add in our actual drill operation, and we're going to add that in the same way. We're going to go to mill part setup, hole machining operations, drill. And we're going to choose our 1/4 inch. Let's see, where is it? Not our center drill, our 1/4 inch drill. We're going to go to features, same hole setup, select OK. It's added in that drill operation, generate toolpath, and we'll go ahead and simulate this. It's got the spots in there. Now it's coming in and drilling those out to the full depth. And again, we're going to add some operations to this so that it pecks as opposed to continuously drills. And we're going to alter our depth on this, and I'll show you exactly why in just a minute. But for now, this looks good. And then finally, we've got all of our machining done. What we want to do now is to go ahead and face this all off. For this, we're going to go to mill part setup. We're going to add in a 2.5 axis mill operation and a face mill. We are going to select our face mill, and for features, we are going to create a feature, 2.5 axis feature. For feature type, this is important. We're going to select a face feature. We're going to select the top surface, and then we're going to select end condition. And we're going to leave this set to up to stock for our end condition. This is how it knows how much material to remove. And if we've done everything properly, our distance here should match that 10,000 added material that we added to the top of our stock. So everything here looks good. We can go ahead and select OK. And then we can go ahead and select OK. go ahead and end that, generate our toolpath, and we'll simulate this. Got our sides, interior, holes, and then let's see. It's coming through and facing that all off nicely. So this looks good. So what we're going to do is we're going to go ahead and edit the parameters on all of these. Now, we're going to be cutting this in wax, but what I want to start to do is to generate the toolpaths as though we're cutting in aluminum. And I want to do that so that we get used to generating the toolpaths, we get used to the cut lengths, because our cut times are going to go up significantly. And that's where we're going to have to start tweaking things to optimize our cut times. So let's go ahead and start with our rough mill. Now we're using our 1/2 inch end mill here, so a lot of these values are going to be pretty familiar to us. For our feeds and speeds, our spindle speed is going to be 2400. And again, I'm getting that value from our spindle speed calculation, which, as we recall, is 4 times V over D. V is our surface speed, which for high-speed steel in aluminum is 300. And D is our diameter of 0.5, diameter of the cutter. So 4 times 300 divided by 0.5 is equal to 2400. Our feed rate, if we go ahead and do our feed rate calculation, our feed rate is, oh, come on, our spindle speed times our feed rate of inches per tooth times the number of teeth. So our spindle speed is 2400 times our inches per tooth is going to be 2000s. That is a value given to us by our tool manufacturer. And then we have 2 teeth on our 1/2 inch end mills. This is going to come out to 9.6 or about 10 inches per minute. For roughing, we don't want it to leave any material. We want this to cut to final size. So we're going to go ahead and set this to 0 for side parameter allowance. And then for first and max cut amount, we can only do 10% of the tool diameter for cut amounts. So that equals about 50 thousandths. We want to make sure to take off machine island tops. Now, you guys may have noticed that when your parts are being machined, when it's going ahead and moving that tool out, it kind of skims the surface. This is the reason why. So that's what we're going to do, is we're going to go ahead and turn that off. For our NC plane, since we've added material to the top of our piece in the term of stock, right? We want both of these to read top of stock, and we're going to set these both pretty low at 0.1, 100th thou. Make sure a CNC cutter compensation is turned off. And then everything else in here should be fine. We don't have to edit any of those. Next, we're going to go to Z level, the 1/2 inch end mill. And a lot of these parameters are going to be the same. Our feeds and speeds, 2400, 10 for our feed rate. For our Z level, we don't want any allowances. We want our method to be constant, our cut amount to be 50 thousandths. We want to cut from the top of the stock to the bottom of the feature. NC plane, top of stock, 100 thou. And then everything else in here should be fine. So we can go ahead and select OK. Yep, go ahead and regenerate that. For our flat area, now if we remember, this came down in one giant pass and hogged out all of that material. We don't want that. So what we want to do is to first see how tall our cut here is. Now this is 3/4 of an inch. That's going to be important in just a second. So for our flat area, we're going to edit this definition. Feeds and speeds are going to be the same for our 1/2 inch tools, 0.2400, 10 inches a minute. In flat area, everything in here is fine. It's not putting in any allowance. What we do want to set is the number of cuts. So this is how many passes it's taking to machine out that flat area. Now, as we recall from just a second ago, our height is 3/4 of an inch. With our tool, we can only cut 50 thousandths of material at a time. So our number of cuts is going to be 3/4 of an inch, 0.75, divided by 50 thou, which is going to be 15 passes. First cut, top of stock. Last cut, bottom of feature. NC, top of stock, 100 thou. We can go ahead and select OK. And you can see what it's done is added in all those features so that it's not trying to hog out all that material in one pass. So this is looking good so far. Now that we've got that all cleaned out, let's go ahead and look at our Z level for our 1/4 inch flat end mill. For feeds and speeds, since our 1/4 inch end mill is half the diameter of our 1/2 inch end mill, our spindle speed is going to be twice as much. Now, we've run into an issue here because our machines cannot handle more than 2800 RPM. They won't spin faster than 2800 RPM. So we're not going to be cutting at the optimal speed, but we're going to be cutting as fast as we can, 2800. Now we're going to take that into consideration when we do our feed rate. So if we go ahead and use this same formula, except we're going to use 2800 here, and our 1/4 inch end mill has three teeth. So if we do some math, we're going to do 2800 times 2 thousandths times 3. And that's going to give us a value of 16.8. We're actually going to round that down to about 15, just for a little bit of a buffer room. For Z level, we don't want to add any allowances, but our cut amount we have to change. We're going to change this to 25 thousandths, 10% of our tool diameter. First cut, top of stock. Last cut, bottom of feature. Okay. NC plane, top of stock, 100 thou. This all looks good. And you can see just how much finer that is in there. For our center drill, now remember, this is trying to drill the entire depth. We don't want that. We want to use an actual drill for that. So for our feeds and speeds, spindle speed, 2800. Z feed rate of 2.8, that's fine. It doesn't have to go down particularly fast. For center drill, we're going to be doing spot drilling. Then for NC plane, top of stock, 100 thou. Clearance plane, top of stock, 100 thou. Under feature options, we want to adjust the machining depth. So we're going to click this override machining depth. And we only want to drill this down about 10 to 20 thou. We don't want this to drill the whole feature, we just want it to put a little divot in there. So we'll put in a 20 thou spot. And that looks good. So 20 thou machine depth, that looks good. For our actual drill, we're going to go ahead and edit that definition. Feeds and speeds. Again, 2800, because we're going to max this out. Feed rate of 2.8 is fine. Drill hole parameters. Now, when this drills, it's not going to drill down in one bore, all right? It's going to peck. And so it's going to come down, go up, come down, go up. And that's going to help remove chips and help reduce stress on the tool. So we're going to choose pecking. Peck amount, it's going to cut 100 thou each peck, which is fine. Dwell amount, that's how long it stays in the hole for. We're cutting in aluminum. It's a very soft material. We shouldn't have to dwell super long. We really don't want that because we want to avoid that heat buildup. So we're going to leave that set to 0. And just like always, we're going to set both of these to top of stock and 100 thou for NC plane. Now for feature options. Now, when we look at a drill bit, the drill bit is going to have that little peak on it, right? That's going to leave that peak in the hole there. So what we want to do is we actually want to drill a little bit deeper, right? We want to drill deeper by the amount of this peak so that this depth here is our full drill depth. So what we're going to do is we're going to add tip length. And you can see it's adding the tip of that drill bit to our depth calculation. We can go ahead and select OK. And then finally for face mill. Feeds and speeds. For our face mill, it's 2 1/4. Times 600, because our face mills have carbide inserts. Carbide on aluminum is 600 for our surface speed. I'm sorry, 4. Let's see, ratio. 4 times 600 over 2.25. And that's going to give us an RPM, a spindle speed RPM of about 1,000. That looks good. Now, when we're cutting with a face mill, we want to leave a good surface finish. It's the primary reason of a face mill is to get us a good surface finish, not necessarily remove material as fast as we can. And in my experience with the face mills that we have, we get a good surface finish between about 4 and 6 inches per minute. So we're going to go ahead, dial this feed rate back to 6 inches per minute. Under facing, there's nothing we have to set in here. NC plane, both of these are going to be top of stock and 100 thou. And feature options, there's nothing we have to set in here. So we can go ahead and select OK. So let's go ahead and see how this all looks now. You can see it's taking much longer on those sides. That's going to be a long time for us. That's actually going to be close to about 40 minutes when we're done with this. That all looks good. And you can see in here, right? It's still leaving a pretty jagged surface finish. And what we're actually going to end up doing is taking a look at our total times and seeing if we can improve this without adding too much time to our overall cut. Because as we remember, we have only 2 hours to go ahead and cut. So let's look at our total tool time. Our rough mill is taking about an hour. Our Z level is taking about 10 minutes. Our flat area, about 23 minutes. Z level 1/4 inch, 15. Center drill is taking practically no time. Our drill also taking practically no time. And our face mill is taking about 6 minutes or so. Our face mill's taking about 3 minutes or so. So what we want to do to reduce our time is go ahead and edit our rough mill, our first operation. And we're going to see if we can't speed this up a little bit, egg it along. So let's go ahead and edit this definition. Now again, we have to remember we're cutting in aluminum. So for feeds and speeds, we can actually kind of cut a little bit faster. We can go ahead, bump our XYZ feed rate up to 15. And then let's go ahead and see what that does. I think that'll save quite a bit of time. You know, we're increasing it by a pretty good percentage. So let's go ahead. After we edit that to 15, let's generate our toolpaths. And let's see what this roughing comes out to. So it's about 40 minutes right now. So what we've done is we've saved ourselves about 20 minutes of cut time. That means we can go ahead and add 20 minutes of cut time to our 1/4 inch Z level. All of this adds up to about 2 hours before any edits. So we've saved ourselves 20 minutes here, so we can add it in here, so that hopefully we can finish this in one class time. So what we're going to do now is edit this definition for our Z level 1/4 inch flat. We're going to go to Z level, and we're going to take our cut amount. Instead of cutting 25 thou, we're going to cut 10 thou. And that's going to increase our toolpath time by about 20 minutes, but we've already saved that 20 minutes up here. So let's go ahead and see how this looks now. Oh, much better. Much better in here. And again, if we had a ball end mill, this would be a lot smoother. But this looks pretty good. I'm not too displeased with that. So this all right now will take about 2 hours, and that's pretty good. So what I want you guys to do is I want you to go ahead and save this, and then I want you guys to go ahead and post-process this. And what we're going to do is we're actually going to end up cutting this part next week in class. But if you have any questions on this, go ahead, shoot me an email, leave me a comment, and I will see you guys in the next video.